So there's also something called a dominant frequency, and that is the idling rhythm of the brain. And it's usually between 8 and 12 hertz, and that's the number of waves. Hertz is the number of waves per second that you're going to see, and so that's what Hans Berger first identified, because that's the dominant frequency of the brain. So that's what he saw first. So of course he called that alpha waves. Very creative, I know. And so the alpha is generated in the back of the head. It's generated usually in the occipital lobes. So what you see here, these are two different views of looking at that alpha. And so you can see the scale, if you're looking at the one on the right, the scale there's more of that frequency. It's the oranger it is, and then down to green's a little bit less, and there's no blue on here. But so you can see right around 12 hertz in this brain, that's the dominant frequency, and it's being produced right there in the back of the brain, in the occipital lobes. And you can see that it's hard to see on the left, but that corresponds to the head and the brain. I forgot to point out there's the ears on there and the nose, you see, so that you can tell which way is the front of the head and which is the back. The left is a bunch of different sites, and you can see that right around 13 hertz, there's a spike in the back of the head, and you can see it a little bit in other parts, but it attenuates as you move towards the front of the head. And that's what your average brain looks like. And if we go on to the next one, this is what we found going on with Lisa's brain. And you see there's not really, you can't really see that dominant frequency being produced there in the back. Instead, if you look on the left, you can see it kind of clearly on the left one there. If the T4 and T6 there that I told you about, that's you can see a spike in that graph right around 9-10 hertz, right? Between 8
Mark,
and 10.
will you walk over and just show?
Sure,
So
of course. Yeah, it's right here. That spike right there, and that spike right there. You can see it a little bit here and here, but that's where you mainly would want to see it. That's where the average, where it would be for most bodies. And you can see it on this too. It's right there and right there. It's showing up at between 9 and 10, a little bit at 8 hertz there. And you can see, okay, it's starting to. There is some in the occipital lobe, but there's something going on, that there's been a shift, I think, a shift in the functioning of the brain. So let's go on to the next slide there. So this, I'm just going to leave this up as we talk. Because then what the QEEG tells us is, okay, there's something going on at that part of the brain. And there's a lot of other information that, for the sake of time, I haven't really had time to share with you. But what that then tells us is a target for what do we want to do with neurofeedback. And what neurofeedback is measuring those waves, feeding that into a computer, and setting thresholds. And basically giving the brain feedback on when it's producing a certain level of a wave, or when it's producing a small enough level of a wave. And then when the brain does that, the computer beeps. When the brain's outside that range, the beeps stop. It's really that simple, but what it's doing is harnessing the power of neuroplasticity, harnessing the power of the brain to change itself. What's most amazing about this to me is you're just giving someone some beeps and some simple feedback on a computer screen, and the brain knows what to do with it. Somehow it knows, it can figure out how to make certain neurons fire faster or certain neurons fire slower. And that's a pretty amazing thing. It's not exactly a conscious thing. I mean, some people will come in and sit down, you'll hook up the sensors on their scalp, and you'll say, okay, I want you to make more of 8 to 10. And they'll say, okay, watch me. Boom, it happens. But that's the exception. For most people, it's really a process of tuning into the body, a process of letting the brain do its thing. And so, to give you the example of what we've been doing for Lisa, we saw that there's a lot of this 8 to 10 activity. And like I said, that's the idling rhythm of the brain. And so what we think is that temporal lobe area, it's not engaged. It's not doing what it's supposed to be doing. It's idling when it really shouldn't be, when it should be doing its thing. And so what we have been doing as far as the training is the message that we've been sending to Lisa's brain is, okay, we're going to see if we can reduce that 8 to 10 activity and consequently get that area of the brain more engaged. And so like I said, this is a brain, and you can see the different parts of the brain are highlighted. These are the 4 lobes of the brain. Occipital is in red, the temporal lobe is in green, the parietal lobe is in yellow, and then the frontal lobe is in blue. And so what we've been mostly working with is the one in green there, the temporal lobe. And what does that have to do with? That has a lot to do with your emotion brain. It has a lot to do with organization. It has a lot to do with motivation and that kind of thing. So as Lisa was saying, she couldn't file papers. This could correlate with that. I mean, we can't say for sure, but we can train the brain and see if we see some shifts. So that's what I wanted to talk about. I want to open it up for questions, comments, feedback at this point, okay?